Right, this is 3.1 materials per purpose. First question asks you to draw out an ionic bond, okay? You had to go on the periodic table and work out what group they're in. So magnesium's in group 2, fluoride's in, or fluorine's in group 7. Remember, the metal always transfers to the non-metal. You needed 2 fluorines then to make it work. That's lost 2, so it's positive 2. That's gained 1 each. Be careful of that, they've gained 1 each, but there's 2 of them, so it's negative 1, okay? Then you were asked to fill in a table, working out, so do top, swap, drop for this one. Top, swap, and then make sure you put it in bracket because there's 2 elements when you drop it, okay? This was then looking at, that one's got a 3, so that must mean that that's positive 3. That one's got a 2, so that must be negative 2. Explain how sodium and bromine atoms form ions. They lose or gain electrons when bonding together. Again, another much nicer ionic bonding question. Be careful of this, where it says include electron structures of the ions formed. Okay, so you have to make sure that you include the new electron structures, whereby that magnesium's lost 2, that oxygen's gained 2. Okay. Magnesium has a higher charge than sodium, larger electrostatic attraction, requires more energy to break the bonds. Okay, imagine it looks like this. So because they're both 2, they've got 2 lines. Okay, whereas these guys are 1, so they've got 1. It's easier to break the 1 bond. This then is a covalent one. Okay, that's in group 6, that's in group 7, so they're both non-metals. So work out how many they need. This one needs 2. This one needs 1, and then swap them over, and then you can see where they share the electrons. Okay, nice easy question then. Given the electron structures of hydrogen and oxygen, work out how to draw the covalent bond. Looking then at covalent structures, explain why diamond has a higher melting point than hydrogen, has more covalent bonds. Hydrogen is a single covalent bond, whereas diamond is a covalent bond repeated over and over again. You might have heard the word giant covalent, and there's needs more energy because you have to break multiple bonds. Okay, explain why diamond is an insulator of electricity and graphite is a conductor. Diamond has 4 carbon bonds. Okay, so carbon, if you drew its outer shell, has got 4 electrons to bond. Okay, what carbon in diamond does then is it bonds 4 times over and over again until you make a really big structure. Whereas in, oh no, I'll leave that there for you. In graphite, it's got 1, 2, 3, 4. So that one, and that one all bond, whereas this one doesn't. Okay, so that one's free then, so it can conduct electricity. Why is graphite soft and slippery and diamond is hard? Graphite is in these layers. Again, with that free electron, it forms these layers which can slide over each other. Spare electrons allow the layers to slide. Diamond does not have a spare electron, so has stronger bonds. Then it says, look at these structures. Give the structure that represents diamond. It's that one, it looks like a diamond going up. Name the element which has structure D, calcium, so that's any metal. Absolutely any metal, so anything in group 1 to 3 would have been in there. Okay. Give the letter of the structure able to conduct electricity. That would be A, because it's graphite. And then sodium chloride. Sodium chloride is a giant ionic bond. Okay, and that's what it would look like. Metals have a variety of applications in industry. Describe metallic bonding. Positive ions surrounded by a sea of delocalized electrons. Explain the properties of metals which allow them to be used to make sheets. They're malleable, so they can be hammered into shape, and they're ductile, which means they can be bent and twisted. Explain why metals used in wires are good conductors. The delocalized electrons are free to move, so they can transmit electricity across the wires. This then is an alloy. If you look at this alloy, it's got 2 different types of metal. So imagine that's magnesium and that's copper. It's got 2 different types of metal within it. Okay. There's bigger and smaller atoms, depending on the size of the atom, the element, which distort layers. Greater force required for layers to slide, stronger than a normal metal. Right. Explain why are made from titanium rather than stainless steel or aluminium. So first off, they're resistant to corrosion, so better than aluminium. They're also less dense and stronger than stainless steel. Give 2 reasons why glass would not be suitable for hip replacements. It's brittle and it's not strong. Nice kind of question here, working out density. Density is a measure of mass of a substance. It relates to compactness of a substance, to how much space it takes up. The density of an object depends on what it's made of. Density does not vary with size or shape. First off, then you have to work out the volumes of each of them. So you're timesing the 3 parameters by them, and then you're dividing it. So density is the mass, and they've given you the mass of each one in the box. The mass divided by the volume, okay, whichever you worked out. Use the graph to explain the largest force at which hooked floor is obeyed. So it's before it kind of bends over, so that's going to be at about 50 newtons. Explain each spring in the trampoline would experience a maximum of 58. Explain where this particular spring is suitable. No, it'll be over the elastic limit, so it would start to snap. Spring constant then is the force divided by extension. So point E, extension is 2.5, force is 52, so 52 divided by 25. Add a line for a one with a smaller springs constant, so it's going to be one below because that number is going to work out smaller. Right, the heat energy passes across the copper bar by conduction, causing wax to melt. The bar gives out heat in all directions by radiation. Energy moves from a warm end to the cold end. Next, then you need to use the graph to work out some of the results. And how long did the drawing pin C take to fall off the copper bar? 30 seconds. Okay. The experiment is repeated with a steel bar. Take 2 things, making the experiment fair. Same mass of wax, same distance from the Bunsen burner.